So for delta math, doing sector area and arc length of the level 2. So this is what you should be running into. So we pulled a couple of the ones that we worked on in tutoring today and some call outs that people have given me throughout the day as far as questions are concerned. So QR equals 5. So we're going to go to QR and you're going to label it 5. So we know that that is the radius because that is from center to outside of the circle. And then it says the area of the shaded sector. So the area of the shaded sector means that they've already solved for the sector area here. And they've left the answer in terms of pi. So area, so sector area equals theta, which is your angle measure, pi r squared, which is area of a circle, divided by 360. Because again, surface area, sector area, you are trying to figure out how much area this slice of pie or pizza takes up relative to the entire circle. So then in that case, we know that the sector area, because it says area of the shaded sector, is 25 over 18 pi. And that goes in the place of sector area. We have our radius. Pi is a given. 360 is a given. Our radius was 5. So we're going to square it. And then our unknown is going to be that angle measure because it says find angle RQS. So we can call it X. You can call it whatever variable you want. That is the unknown of this problem though. So first we're going to try to get the 360 out of the denominator. And to get it out of the denominator, that means it's being divided by 360. So the inverse of division is going to be multiplication. So we're going to multiply both sides by 360. And that's going to make, once we simplify it all the way down, these two 360s would go away. And then 360 times 25. And I'm going to write it out all the way through because depending on the questions and what form they want the answer left in, it's going to be more helpful to keep it in all, so you can see all the forms as you work your way down instead of just shoving all this into the calculator at one time. So we're going to have 9,000 over 18, and that's pi. And so that's 360 times 25 was 9,000. And we can check that and see if it's divisible by 18, and we might get a nice whole number, which in this case we do. So it's going to be 500 pi. Go over here and clean up this side. So I have pi 25. So x times pi times 25. So x times pi times 25. You are ultimately trying to get x by itself. So it's x times pi times 25. And the inverse of multiplication is going to be division. And you can do this one at a time. So if I decided to divide by pi, our pi's are going to go away. And just by dividing by pi that time, we now have 500 equals 25x. X is still not by itself. It says x times 25. So we're going to divide by 25. And you get 20. So x equals 20. And in this case, you want to make sure you remember that the x is theta. So x equals 20. So that means angle RQS is 20. It is small, so that looks correct and sounds correct. So we're going to go with the angle RQS is 20. All right, so to do another one. So circle J, KJL. So KJL is 45 degrees. That's going to be theta. And the area of the shaded sector is 1/2. So again, they've already done it for the area of all of the shaded sector. So we know it's sector area again, theta pi radius squared over 360. And we fill in what we know. So in this case, we do know that the sector area, because it says area of the shaded sector, is 1/2 pi. So we're going to put 1/2 pi on this side of the equation. It's our output. We do have our theta. So this is important because that's our angle measure. So 45 degrees. So theta, pi is a given. 360 is a given. And what we're missing is our radius squared. So find the length of JK. JK would be our radius length. So we'll just put an X there to know that that's the unknown of this problem. So again, we still have 360 in the basement. So we're going to multiply both sides by 360. Which once simplified makes it go away here. Whatever you do to one side, you have to do to the other. So 360 over 2 would be where we are right now. Pi, which half of 360 is 180 pi. And then we have 45 times pi times x. So here again, we can do divide by pi and then divide by 45, but we're going to divide by both. So we could do it all at one time. And because there's a pi at the top and the bottom, these are both going to go away. These are both going to go away because like any other fraction, like 3 over 3, it makes that a 1. Same thing, so 45, 45, that's 1x now. So we're down to 1x. And then we have 180 divided by 45, which is going to give us 4. So our radius, or length of JK, is 4 for this guy. All right, so circle C, DCE is 72, so DCE is 72 degrees. So again, this is theta given. And the length of, and this means arc, so the arc length. So now we're not doing area anymore, sector area, we're doing arc length. So our formula changes. So arc length equals theta 2 pi r, because that's circumference, because remember this is a portion of the circumference of an entire circle. So we're going to take what we know and put it in the place that we need it. So we have a theta, and we have the arc length, so that's going to go on this side of our parenthesis, or our equal marks, because it is the output. It is what we typically are solving for. Our degree measure, or theta, is 72. 2 will always be there. Pi will always be there. And we're going to divide by 360 every time. And this is asking for the length of CD. So length of CD, which is going to be our radius. And again, this is arc length. So 2 pi r is circumference, and then it's 72 over 360, portion of the entire circle. So just like before, we're going to multiply both sides by 360 to get it out of the denominator, or the basement, as I like to say. So these guys cross out. Whatever we do to one side, you have to do to the other. So 360 times 6 is 2,160, and obviously it's divided by 5. So if we divide that by 5, we end up with 432 pi equals, and I have 72 times 2, which is 144 pi radius. So just clean that up. Now again, I want the radius by itself. So we're solving for r, and we can call it an x if you want to, like we did in the previous ones. You can call it r, whatever. It's a variable. You can call it any letter you want. It can be your initials. We need to get the 144 times pi off that. So the opposite of multiplication is we're going to divide both sides by 144 and pi. And just like the first example, you can do it one by one and make that 2 steps. But you're definitely going to divide by pi. And we're definitely going to divide by 144 because that's how we get r alone. So 432 divided by 144 gives us 3. So length of CD, or the radius in this case, is 3. All right, I got one more for this section before our next video where we're going to work on the mixed section of that delta assignment. All right, circle H. HI is 3. The arc length, so you see the word length, so that means we know arc length equals theta 2 pi r divided by 360. And in this case, that arc length is, so that means the length of this is 5 over 6 pi. So it's in terms of pi. So we're going to put that in the place of arc length equals, we don't have a degree measure, so our unknown is going to be theta. And I'm going to call it x. You could put a t if that helps you remember that it's theta. 2 and pi are always part of this formula. So 2 pi 360, always going to be part of this formula no matter what. And then we had our radius over there, and that was a 3. And this is length, so it's just radius, not radius squared. So again, we're going to try to get that 360 out of the basement. So we're going to multiply, because it's in the denominator, because it's all of this divided by 360, and the inverse of division is multiplication. So multiply by 360. 360 times 5 is 1,800 over 6, and that's just pi. So if we divide that by 6, and we get a nice, neat whole number, we get 300 pi. And that's going to be equal to x times 2 times pi times 3. So 6 pi. because our 360s went away here. So 6 pi x, so we can leave the x in the front, and then 6 pi. So again, you're trying to get x by itself, and that's x times 6 times pi. And the inverse of multiplication, again, is going to be division. So 6 divided by 6 pi, divided by 6 pi. So our pi's cross out because they make a 1. 6 divided by 6 is 1. Pi's cross out because that makes 1. And then 300 divided by 6 is going to give us, whoops, I did that wrong. I was going to say 1. Whoops, let's say 100. That's not right at all. 50 equals x. So in this case, our theta, the degree measure, is going to be 50. Now, the question says, find the area of the shaded below. So we need every time theta and radius to solve for either. We have our radius. We do not have a theta until we did this math. You had to do this formula because they gave you the length. Now we're going to find the area of this shaded region and express it in terms of pi. So again, sector area is theta pi r squared all over 360. We are solving for sector area because that's what it asked for. Find the area of the shaded, express your answer in the fraction times pi. So we have 50. 50, this is less than 180 along with 50, so that's perfect. That's going to be our theta. So we're going to have 50, our pi, and the 360 is all the time. We're trying to solve for sector area. That's our unknown. And our radius in this case is that 3 squared. So that's going to be 50 times 9. Because 3 times 3 is 9. So that's going to give me 450 pi over 360. So if I type in 450 divided by 360 into Desmos, you will see over to the left-hand side it looks like a little fraction where they normally have the colored when they're graphing the line. If you click that, it will simplify that fraction for you because you do need it in fraction form, like they said, with pi. And so you're just going to leave pi alone, like not push the button. And then we're going to be 5 over 4 pi is the sector area. So a lot of math, and there's going to be dummy answers. If it was a multiple choice question, 50 would be there. But the final answer to the actual question, find the area shaded below, is 5 over 4 pi. All right, guys, I hope that helped a little bit through those level 2 problems that were assigned yesterday. If you need me, holler.